4.4. Reactions in organic compounds. Learning outcomes. At the end of the lesson, the students should be able to A. Explain covalent bond cleavage. Homolytic. Heterolytic. B. State the relative stabilities of primary, secondary and tertiary free radicals, carbocations and carbanions. C. Explain the inductive effect of alkyl group towards the stability of carbocations and carbanions. All chemical reactions involve bond cleavage and bond making. There are two types of bond cleavage: homolytic cleavage and heterolytic cleavage. The table shows the differences between homolytic and heterolytic cleavage. Homolytic cleavage occurs in nonpolar bond involving atoms of similar electronegativities, whereas heterolytic cleavage occurs in polar bond involving unequal sharing of electron pair between two atoms of different electronegativities. For homolytic cleavage, single bond breaks symmetrically, and each atom get one unpaired electron. Whereas, for heterolytic cleavage, single bond breaks unsymmetrically where both the bonding electrons are transferred to more electronegative atom. Thus, homolytic cleavage will form free radical as intermediates, and heterolytic cleavage will form cation and anion as intermediates. There are three types of reaction intermediates: carbocations, carbanions, and free radicals. They are unstable and highly reactive. Carbocation, carbanion and free radical can be classified to primary, secondary or tertiary, depending on the number of carbon atoms directly bonded to it. Different classes of reaction intermediates has different stabilities. Carbocation stability. The stability of carbocation increases with the number of alkyl groups present. Alkyl groups, also known as electron donating group, is electron releasing relative to hydrogen, which will help to stabilize the positive charge on the carbocation. Number of alkyl groups attached to the positively charged carbon atom increases, the stability of carbocation increases. Methyl carbocation has no R group, thus it has the lowest stability. Stability of primary carbocation is less than secondary carbocation, and tertiary carbocation is the most stable among them because of the presence of 3 R groups. Example: as the number of alkyl groups increases, the stability of carbocation increases. Carbanion stability. Alkyl group and other electron-donating groups destabilize carbanions. As the number of alkyl group increase, the stability of carbanions decrease. Electron withdrawing group, for example, halogen, will stabilize carbanions through the inductive withdrawal of electron density. Among tertiary, secondary, primary and methylcarbanion, tertiary carbanion is the least stable one because of greatest number of alkyl groups bonded to it, whereas methyl carbanion is the most stable one. Example: as the number of R groups increases, stability of carbanion decreases. Free radical stability. The stability of free radical increases as more alkyl groups are attached to the carbon atom with unpaired electron. Relative stabilities of free radicals. Among all the classes of free radicals, tertiary free radical is the most stable free radical, followed by secondary and primary free radical. Methyl free radical is the least stable one. Example: increasing alkyl substitution, increasing radical stability.